begin, I would just like to say on behalf of all the ambassadors, thank you so much for the Gateway to Equity Award. It really means a lot to us, especially from our perspective. For so long, and just this organization is really important to me because if it wasn't for an upper level student in one of my high school classes, I wouldn't be an engineer. So being able to give back is just fantastic. So thank you so much. That being said, so Megan and I are going to give you a sample presentation. It's a little bit shortened of what we would usually do. So the topic is biomimicry, and it should typically be given in a biology class or maybe a physics class, depending on what material they were learning at the time. So what I'm going to ask you to do is it's sort of interactive, so I'm going to ask you to forget everything you knew or everything you've learned since 9th grade and put yourself in the mindset of a 14, 15-year-old high school student.
All right. So the solutions to engineering problems can often be found right within nature, so we're going to have a little fun. I'm going to show you a series of pictures, and you have to tell me, or Kim, exactly what you think inspired that design. So this first one is probably the easiest. What do you think this is modeled after? Feel free to yell out. Bird's nest. All right. Well, this is indeed the 2008 Beijing Olympic Stadium, otherwise called Bird's Nest. So this was indeed modeled right after the bird's nest. It was designed to look just like this naturally occurring nest from nature. All right, the second one's a little bit harder. What do you think this fan was modeled after?
When there's some seeds that fall in.
You got it. All right. Wow, that's the first time anyone ever got it. All right. So this fan is indeed modeled after a... Maybe you remember when you were growing up, hanging out underneath a sycamore tree and seeing how the leaves fall, or the seeds fall from the tree, and they spin really rapidly. So engineers kind of took this phenomenon that occurs naturally and tried to figure out how to implement them in fans to make it really, really efficient, just like these falling seeds. All right, so this is a futuristic building. What do you think this could have been modeled after?
Honeycomb?
Yeah. Honeycomb. That's a good one. Not correct, close. Any other guesses? All right, so this building is a futuristic building that's modeled after a plant cell, more specifically an onion.
Oh, cool.
So kind of cool. So you can see just how this building looks just like this plant cell. So what we're going to talk to you about today is how engineers take inspiration from nature and things that occur naturally to inspire their own designs and innovations for the world today. So I'm Megan Fisher.
Kim Harrison.
And we're going to continue our presentation.
All right, so how many of you heard the expression that you are blind as a bat? All right, so if you take a look at this furry creature here, what you might notice is that the eyes are really small, especially in comparison to his ears, right? So one thing you might not notice is that bats actually see using their ears, and they do this through a process called echolocation. Now, echolocation sounds kind of intense and scary, but you're probably familiar with the concept. So if you ever stood in between two really tall buildings, or maybe you were lucky enough to visit the Grand Canyon, if you ever yelled out, maybe you yelled hello, you can hear that echo coming back at you. Kind of
Actually. So what bats do is they send out sound waves, and when those sound waves interact with things like a wall or an insect, it bounces off of that object and comes back, and it's collected in their ears. And their ears are really, really advanced, they're really technical, and they're really actually a marvelous machine. And the bats are able to figure out where objects are based on the different sound properties. So scientists and engineers are thinking, well, this is really, really good. We can use this to our advantage. So one thing they have to know are the properties of waves. So sound is a wave. You can think of it like a wave at the beach where it goes up and down, and they have different properties. So one of the properties is called amplitude, and that's basically just how high this wave will go. So amplitude is related to the volume of the sound wave. So if you're in your car and you turn up the sound, all you're doing is you're increasing your amplitude. Another property of waves is called the period, and that's basically just how long it takes to get from one point to the next. Now, period is also related to something we call frequency. And so when you shorten the period, you increase the frequency. So if you have a dog and you have one of those really high-pitched whistles, your dog can pick up that frequency, but our human ears cannot. And so that's how those dog whistles work. That's also why when bats are using this echolocation, you don't hear them all the time, because that would be really annoying. So scientists and engineers need to know these different properties in order to calculate distances between objects. So they actually use this in a process called radar. So I'm going to give you a little example here. Here I have a satellite, and I'm just going to send some waves out, and they're just going to propagate through space. But you can see there's nothing interacting with them right now. So if we have a plane flying in the sky, and we send out these waves again, what's going to happen is when these waves hit the plane, it's going to bounce back and be collected by that satellite, much like the bat's ears. So
using this information, scientists have a computer that they punch some numbers using the amplitude and the period of the sound waves they send out, and they can calculate the distance of this plane. And they can also calculate things like the speed at which it's moving. So this is really useful because if I were to ask you, how high can you jump? You'd probably use something like a ruler or measuring tape to measure that. But I don't think that you find a ruler high enough to measure the distance an airplane is from the ground. So scientists and engineers found a way of using waves that we can measure how far things are away from each other. Now, it's not just in air that this is used, but also in things like submarines. So in the ocean, at the depth that submarines are traveling, it's really dark and they can't see. Unlike when you're driving at night, you can use headlights to illuminate things. However, scientists use the same principle of sending waves out. And you can see here, they scan the area around them and it can pick up different objects based on that property of waves bouncing back and forth. So that's essentially how ship captains or submarine captains are able to safely maneuver the seas.
All right, so now we're going to talk about everyone's favorite time of year. And no, I'm not talking about Christmas, I'm talking about Shark Week. Everyone loves Shark Week. So what's really cool about sharks is scientists and engineers are finding so many innovations that are coming right from the shark. So one of my favorite ones is actually the skin of a shark. And the skin actually allows them to be very, very aerodynamic as they swim through the water. Now, has anyone gotten a chance to pet a shark before? A couple? All right, so they feel kind of similar to snakes, where it's going to be really smooth one way, but then really rough the other way. That's because shark skin has scales. And more specifically, it's not just scales, it also has grooves. So how do these grooves actually help sharks swim faster and more efficient? Well, I'm going to explain this first by saying what would happen if they weren't grooves, what would happen if they were flat. So if you know anything about turbulence, what would happen if water just got rid of this scale is it would go straight first, and then as it goes off, it would get really, really turbulent because the water has no specific direction for it to flow. This is very similar to if you're on an airplane and you're kind of getting the turbulence in the back and it's all bumpy. You don't like that. So if that would happen for sharks, they wouldn't swim as fast. So what these grooves do is they give a very specific channel for the water to flow through. This reduces the turbulence and lets sharks have a smoother ride through the water. In addition to the grooves, they're also very geometric in that they're thinner on the entrance and thicker on the exit, so that when water goes through it, when it gets to the end, it's going to go through faster. So there's just two ways with how the grooves and the naturally occurring shark skin actually makes them swim faster and more efficiently. So how is this technology being used exactly? So most of you probably know who Michael Phelps is, the Olympic swimmer. Well, Speedo and also Nike have found ways to implement this technology into their swimsuits. So these swimsuits are actually allowing these Olympic athletes to swim just a little bit faster to help beat the competition, which is pretty cool. This technology is also being implemented in buses and cars. So this bus actually on the very front fender has these shark scales put on them to make it more fuel efficient. It's just a really cool way to use shark technology to kind of make a healthier, happier world. So another thing that they're doing is they've also found that shark skin is a natural repellent of microorganisms. So they're taking this technology and putting it into hospitals. So, surfaces that a lot of patients are going to be touching, such as railings, maybe doorknobs, that sort of thing, they're putting on there to help increase the sterile and cleanliness of hospitals. So last but not least, sharks have a very distinct way of swimming, the way their tails move back and forth. So scientists are figuring out how to take this motion and use it to create electrical energy most efficiently for humans. So it's pretty cool. So from this presentation, I hope that you'll be able to see how engineers take inspiration from nature and biology to help increase the health, happiness, and safety of the world. Thank you.